to talk about piecewise functions. The reason it's called piecewise, just imagine I have this graph, and basically it takes pieces of various functions and puts them on the same graph, but they don't overlap. So, for example, I could have, let's say my graph is cut into 3 different sections, and over here I could have a parabola, and over here I could have a line, and over here I could have absolute value, and that would be a piecewise function. So basically cutting and pasting different pieces of various functions together on the same graph. The first thing I'm going to show you how to do is evaluate, meaning how do I plug things in. Well, what we have over here, where it says if x less than or equal to 2, if x is greater than 2, this is the domain. And it tells you what equation shows up where on the graph. So for example, for number 1, where everywhere that x is less than or equal to 2, remember less than being the left side, so the left side of my graph, I'm going to have x squared minus 1 as the graph. But once it gets to 2, it's going to switch to 4x plus 1. So half of this graph is going to be a parabola, and the other half is going to be a straight line. And so knowing how to plug in, I just have to follow the domain. So I'm just going to label these 1 and 2, just so when you're looking at the notes you can know where I went through. So for x equals 0, well, I know 0 is less than or equal to 2, which means I plug into the first equation. So we get 0 squared minus 1, which gets me negative 1. I do not plug into the second equation because 0 is not greater than 2. Right? I go to x equals 2. Well, 2, is it greater than 2 or less than or equal to 2? It's less than or equal to 2, so I'm also going to plug into the first equation. So I get 2 squared minus 1, that's 4 minus 1, which gets me 3. And for part C, 4 is greater than 2, which means I'm going to plug into the second equation. So we get 4 times 4 plus 1, which is 16 plus 1, which gets us 17. For example B, I'll do the same thing. Notice when it has negative 5 less than or equal to x less than negative 1, I just think like x is between negative 5 and negative 1. For the second equation, x is between negative 1 and 3, and the third one, x is greater than 3. This notation means plug in 3. So it's like x equals 3 right there. In fact, I'll write it that way. And so I look, I'm just going to label these again. You don't have to, I'm just doing it so you know where I'm picking it up from. Well, negative 1 is less than, let's see, 3, because I don't actually want to write it that way. Let's just talk through it. All right, I'm going to choose my second equation because if I look here, I have less than or equal to 3. Well, x is 3, which means I can plug into the second equation. So I do 3 minus 1, which gets me 2. Part B, x equals 0. Well, that falls in between negative 1 and 3 as well. So I'm going to plug it into the second one. For x equals negative 4, well, I can look at my first one, x being between negative 5 and negative 1. Well, negative 4 is between negative 5 and negative 1, so I will plug it into the first equation. So I got negative 4 plus 1 squared, which is negative 3 squared, which gets me a positive 9. And for my last one, 18, well, 18 is definitely greater than 3, and so I'll plug into the third equation. That's 2 times the absolute value of 18. Well, absolute value just takes it and makes it positive. It already is positive, so it's just 2 times 18, which gets me 36. So now that's evaluating. Let's talk about how to graph. The first thing I'm going to want you to do is split your graph into sections. Based on the domain. Here's what I mean. Once again, here's the domain. I'm going to look at any numbers that are in my domain. So for example A, it's 2. And I'm going to go to where x is 2. And I'm just going to section it off. I don't care if it's a straight line or if it's a dotted line. I should say solid or straight. Let's just do example B. Here's the domain. I can go to -3. I can go to +5. 1, 2, 3, 4, 5. And then I go to 9. So those are my different sections. And now we're going to graph each equation, then we're going to erase the parts that we don't need. Some things I also want to remind you, if you have a less than or a greater than sign, this is going to represent an open point. If you have less than or equal to or greater than or equal to, it's going to be a closed point. And then less than always represents the left of an x value, and right side always means the right. Sorry, the greater than means the right side. All right, here's what we got. I'm going to color code because I believe in color coding. Let's start with x plus 1. Well, these are linear equations. So I have y equals mx plus b, where b is always the y-intercept, and m is always the slope. So for my first equation, my y-intercept is at 1, so I can start there. My slope, because I don't have a number here, is also 1. And in terms of rise over run, we can make any number a fraction by putting it over 1. So I'm just going up 1 over 1 in both directions. And I'm going to stop when I get to that boundary. This is less than 2, so I see it's on the left. And because it's less than 2, not just less than or equal to, I'm actually going to leave an open point there. And that's all I need to graph for the first one. For the second one, my y-intercept is -2. My slope is going to be -1, so I'm going down 1 over 1 in both directions. When I get to 2, because it's greater than or equal to, I do leave it as a closed point. And so as I connect my graph, I realize, wait a second, I don't need anything on the left of 2 because it only equals the second equation when it's greater than or equal to 2, meaning on the right side. So I can just go through and erase what I don't need. And there's my piecewise equation. I could erase this line as well. I don't really care if you leave it on. If that helps you, that's great, but just know that is what that graph would look like. So for some reason having it in red is bothering me, so I'm going to redo them in black. Maybe because red is just such a vibrant color and I don't want to deal with it this early in the morning. I'm going to make them dotted lines this time. Ooh, look at me go. 4, 5, 2, 3, 4. Okay, let's do the same thing over here. We'll start with x minus 2. Once again, this is a linear equation. I know that because x is not being squared or has absolute value or anything like that. And so my y-intercept is -2. And my slope is 1 because there's no number there. So I'm going up 1 over 1 in both directions. And I see that x is supposed to be between -3 and 5. Well, so I'm in the correct boundary already. And what I'm going to do, once it gets to -3, since it's less than or equal to, that means I can put a closed point. But as soon as I get to 5, that's going to be an open point because it's just the less than 5. So there's that piece. And as far as 6 goes, that's the same as like 0x plus 6, meaning I don't have a slope, but my y-intercept is at 6. 1, 2, 3, 4, 5, 6. So no slope means that I'm just going to come through. And it's only supposed to be between 5 and 9. 5 is going to be closed because it has the or equal to. And the 9 is going to be open. And then I could just go erase everything that we don't need. And you can leave the boundary points, the boundary lines there, or you can erase them like we did with part A. That's fine. Something that I want you to recognize no pieces of graph will ever be in the same section. Which is why we're erasing. That's also why when you get to these boundary lines, like one of them is open, one of them is closed. Like here on this line, the purple equation has a closed point, the green equation has an open point. It's because they can't overlap. Otherwise it would not be a function. Let's see, let's do some more graphing. Yeah, we'll be good. All right. Let's do part D, and I actually want to change this from being 3 to being -1. And so the first thing I'm going to do is I'm going to draw in my boundary at -1. All right, so now we're going to graph parabolas and we're going to graph absolute value. All right, so let's start by graphing the parabola. Luckily, this is in vertex form. And just a quick refresher about that. Where HK is the vertex. So for this one over here, my vertex is at -3, 0. My A value is 1 because there's no number out front, so I can put an invisible little 1 right there. And to graph parabolas, we always follow our growth rate of 1A, 3A, 5A. So since A is 1, 1 times 1 is 1, 3 times 1 is 3, and 5 times 1, that's supposed to be 5. 5 times 1 is 5. So I'm going to start by plotting the vertex. I have 1, 2, 3. And from that point, I'm going over 1, up 1, over 1, up 3, over 1, up 5. Do the same on the other side, over 1, up 1, over 1, up 3. But when I get to this boundary, because it is less than -1, that's on the left, so we're already good, we're on the right spot. And it's going to be an open point. And that's that one. All right, our absolute value equation, turns out, is also the same as vertex form. It just has absolute value instead. So HK is the vertex. So my vertex here is going to be 2, -4. 2, -4. and a is going to be your slope in both directions. So because a is 2, that's like a 2 over 1. There's my rise over run. So I'm going up 2 over 1 every time. And when I get to my boundary, because it is greater than or equal to at this point, it's going to be a closed point. Okay. Should we do one more for good measure? Let's do one with 3. See, -2, +2, vertex form, which is great. My vertex is at -4, 0. A is 2, which means when I follow 1a, 3a, 5a, 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. 2, 3, 4. For 1, up 2. For 1, 1, 2, 3, 4, 5, 6. 2. And get to 6 because it is just less than right there. That means it's going to be an open point. And we graph. All right, second equation. That's absolute value. So my vertex, because there's nothing in with x, that's going to be a 0. And then the number afterwards is a 2. My a is 3, which using rise over run, so 0, 2, up 3, 1, 2, 3 over 1, 3 over 1. So on the, looks like both of these have the or equal to, which means it's going to be solid at both. So that's just going to fill in. That's nice. And we can connect. And then my last equation is linear, so my y-intercept is 1, 2, 3, 4, and my slope is -1. So down 1 over 1, down 1 over 1. Looks like at 2 it's going to be open. Down 1 over 1. Keep going. And I only need that piece because it's on the right, because it's greater than. So that's the right side. So then I can just go back and erase what I didn't need. I'm going to have to redraw the other one, and that's okay. Right. And let's pause and make another video for the next one.